So the webinar is why Looker for Google BigQuery Enterprise Data Warehouse. What we'll cover here today will be a quick introductions. In case you haven't seen Looker yet, a bit introduction to what the Looker is about. We will talk about a little bit about Google Cloud Data Management, what it consists of, what are the products there. We'll dive into why the Looker with BigQuery, how we see it. We'll cover one case study and then Q&A. So without waiting any further, my name is Darius Kemaklis. I run Google Cloud Consulting Practice at Myers-Solom. And with me, we have also Bruce. Bruce, you want to introduce yourself?
Yeah, hi everybody. My name is Bruce Sandell. I'm a senior sales engineer at Looker. I work on our technology alliances team, so I support all of our technology partners. And I've been working with Google and BigQuery and supporting our relationship with them for about 3 years.
Thank you, Bruce. From a very quick, just a couple seconds on what Myers-Solom is about. We are a consulting company specializing in IT services and data and analytics space. We've been in business for quite a bit of time. Headquarters New York City, full services. We do both strategy as well as delivery work, and we've done a lot of data warehousing work before Google and after Google. So why we thought about bringing this webinar to you is that we see that companies are facing a lot of pain points with how expensive existing data warehouse technologies are, especially if they're using appliances. And a solution, in our opinion, is to bring data to Google BigQuery, from Teradata, Exadata, Netezzas, Verticas, et cetera, et cetera. When you do that, you will also most probably going to need to rethink your BI or analytics approach, and this is where we think Looker comes into place. And what we can help with specifically is with the approach and methodology and best practices of how to get both data warehousing as well as your BI layer migrated the most efficiently and really get the most value out of the both new technologies. Bruce, do you want to talk about the Looker overview?
Absolutely. Thank you very much, Darius. So Looker, we describe Looker as a unified platform that delivers actionable business insights to employees at the point of decision. So that might sound like a lot of marketing speak, but I'm hopeful at the end of the next couple of slides that it'll make more sense. So as you may know, we have recently been acquired by Google. So our relationship with BigQuery and the BigQuery team has only gotten stronger. So there's 3 basic pillars of Looker that really differentiate Looker. The first is our 100% in-database technology. And what this means is that Looker doesn't store any data. There's no proprietary data store. We don't cube any data. We don't move any data. Data is accessed directly from the database, which helps you maximize your investment in BigQuery. Besides taking advantage of BigQuery's speed and scalability, Looker supports all of the innovative new features that BigQuery releases, such as BQML for machine learning, geospatial, external tables, materialized views, user-defined functions, and nested fields. And I believe Darius is going to talk about a few more of those in more detail later. The second pillar is our semantic modeling layer. And this is one of the key features that makes Looker so powerful. The modeling layer is where the data analysts define what data is available to users, who has access to which data, and it also becomes the single source of truth for defining business metrics. So using this single source of truth opens up the door to users for doing their own self-service analytics because you don't have to worry anymore about users coming up with their own definitions for complex business metrics. Everybody is using the same unified set of business metrics for their reporting. And finally is our web application architecture. Looker is entirely web-based, which means that there's no client software to download, and that Looker is available from any of your web-enabled devices. It also means that Looker visualizations are easily embedded into other web pages, and Looker has a full REST API that you can use as well. So here's an overview of Looker's architecture. We'll work with you to centralize all the data that drives your business into BigQuery, which will become your single source of truth for all of your business analytics. Looker sits on top of BigQuery, and users will work with Looker's intuitive click and drag interface to create reports and visualizations, and then Looker will generate the SQL for them and send it to BigQuery. You'll define your business metrics in Looker, set your permissioning and security as well, and all of your code development is done similar to a standard engineering development process. The code is all stored in a Git version repo, and developers are all using their own branch in Git so that they're not interfering with each other or any production users. Looker runs entirely in the cloud, which means that we take care of all of the management, maintenance, and upgrades for you. And then you can use Looker to access your data in a number of ways. And so this goes back to what I said earlier about Looker being a unified data platform. So first, you can use Looker for just what you'd expect, your BI and analytics for reporting, creating dashboards, and self-service analytics. The next use case for Looker, which is very popular, is integrated insights. So this allows you to take data from Looker and take action in other tools. So we have about 24 built-in integrations with third-party tools. So for instance, if you were to use Looker to curate the exact list of users that you wanted at your next event, you could send that directly to Marketo and have Marketo initiate a marketing campaign for you with that set of data. Also, just about any time you're looking at data in Looker, you can click on a dashboard tile and set an alert. So if there's a dashboard tile where you want to be notified if something drops below a certain metric or if other changes occur, you can do that from the dashboard almost anywhere that you're working with it. And finally is building with Looker. So using Looker's API and embedding functionality, you can take the visualizations that you create in Looker and embed them into the applications that your user base is using the most. So rather than having to go into Looker as a separate tool to look at your dashboards and visualizations, you can embed them into Slack, you can embed them in Salesforce, Zendesk, so you can put the data where it is that the user are actually using it. And then you can use our API to build completely custom data experiences for your users. So you can build pretty much anything that you can think of using a combination of Looker's embedding and Looker's API. Thanks, Darius.
All right, thanks, Bruce. So I hope everybody enjoyed a bit of about what Looker is about from a platform perspective. Next, we will talk about what Google platform is about, right? So Google has over 9 products that have 30 billion users, right? In order to facilitate that type of capacity, Google had to, over time, build a custom software, custom hardware, custom data centers, because you couldn't actually buy it, right? Technology to facilitate that scale just did not exist. Along the way, Google just started providing these capabilities, these products within what's now called Google Cloud Platform. One thing to notice is the amount of investment that Google puts into GCP, into various technologies, data center build-outs and whatnot. And I think what makes it really unique compared to other cloud vendors from what we've seen is really those lines in the background, right? Google actually has a dedicated network capacity that connects Google's data centers. This might not sound very exciting, but the capacity and latency that's available through Google Cloud allows Google to provide some capabilities that just don't exist in any other cloud products, which is things like immediate consistency, strong consistency, and things like that. One thing that I wanted to mention is there is a big push these days into what's called serverless computing, and we think that's super important, especially in the future when you start to talk as people get more data. Instead of thinking about hardware nodes and disk spaces and memory, really it's what people should really worry about more is business capabilities, right? And allow the platform to scale itself. So a lot of the Google products in data management space are serverless, right? So there's obviously machines behind the scenes, but you as a customer don't have to manage them. You don't even have to worry where they are. Google SREs do that for you. One thing with Google is I'm sure everybody heard about MapReduce and some other open source papers that Google published over years, which then spawned the whole open source ecosystem, right? So Hadoop came from MapReduce paper, NoSQL came from Dremel, TensorFlow and Beam are newer open source technologies that Google has been open sourcing. What's different these days is that you can actually use those products as offerings right within Google infrastructure, right? So you don't have to actually go back to open source and figure out where you're going to run it on your own machine set, but instead you can use serverless technologies that Google provides. Google has a lot of different what we call hexagons or products in its space in a GCP offering, and here are a collection of few of them that play within data management, data warehousing, data lake, business analytics side of space. If you go on the left side on the data capture side, so data can be brought in either through near real time with the Cloud Pub Sub, which is messaging service, or if you have a lot of data either on other cloud providers or even on-prem through different data transfer services. So that is actually either virtual or physical transfer capabilities. Once data is in Google Cloud, you can process it using different ETL, ELT tooling and frameworks. So Cloud Data Prep, as an example, is a data preparation and analysis tool. Cloud Data Flow is really Apache Beam, hosted Apache Beam offering, which allows you to build pipelines that can be coded for both streaming and batch with the same amount of code, just changing sinks and inputs, which is very exciting. You can actually run data proc clusters, which is a Hadoop clusters if you want to. There on the bottom, there is fairly new product called Data Fusion, which is a more traditional ETL-like technology. You know, if you have Informatica or talents, it would be familiar to kind of look and feel of where you do drag and drop integration. On the very bottom, there's a Cloud Composer, which allows you to do orchestration. And orchestration is expressed as Python-defined DAGs, acyclic data graphs. And because it's Python, you actually can do quite a few things yourself, right? So it's very extensible, and especially in ELT type of use case, it fits very well. And then there's also data catalog to be able to keep track of all the moving pieces and different products and deployments you might have. For storage, Google offers cloud storage and BigQuery, among other relational databases, which are more OLTP centric. So we're only going to talk about these two storage technologies, which are OLAP centric. The one nuance to mention is that since BigQuery separates compute and storage, storing your data right within cloud storage, blob storage versus in BigQuery actually costs the same amount of money, right? So we typically recommend to store data right within BigQuery, because that forces you to define schema and makes it easier to consume. But sometimes people bring data into cloud storage and then load it from there into BigQuery. BigQuery is also used as a main data warehouse for Google, right? It has both it's able to access data as well as process it. We'll talk about a few capabilities that exist there for it in a few minutes. On the consumption side, we are very excited about Looker, Google acquisition of Looker. We actually, as Microsoft, started working with Looker about 3 years ago, and we thought that Looker had very good complementary technologies to BigQuery, to data warehousing on BigQuery. You can also use cloud AI services. So Google is definitely a leader in a lot of machine learning capabilities, AutoML and whatnot. A lot of those capabilities are directly integrated with BigQuery. TensorFlow, Sheets, Google Data Studio are all different use cases, different products that you can use in order to access and analyze and process data in BigQuery. Actually, and also access it directly as well. So I want to spend a few minutes talking about what BigQuery is, right? So typically data warehousing technologies, as you see on upper left, storage, compute, they all offer it. One thing to mention is that BigQuery separates, again, BigQuery compute and storage, which allows you to really, if you have a lot of data but not querying it very often, allows you not to have to pay for it, right? If you have, you can separate consumption models as well, right? That's very important. We have it has serverless capabilities. The serverless capabilities allows you to not to worry about hosts and machines and whatnot, and just use the data. It has predictive analytics. It has a lot of good data sharing capabilities for within your organization or outside because of separate compute and storage. It allows you to bring data in real time, which is very exciting because you can actually stream data right within BigQuery and analyze it right away. And not to worry about where it's stored and how it's stored. Right? And then at the very end, there's a lot of security capabilities built in for row-level security, etc. All right, a few minutes on a architecture. BigQuery, as I mentioned, separates compute and storage. In the middle, there is a distributed network, which distributed network memory shuffled there with a petabit network, which allows these two components to quickly exchange data. This what allows you to really process data fast and efficiently and scale to massive needs, because these clusters are available. Capacity is just available. You don't have to pre-provision it up front. You can access BigQuery through ODBC, DDBC, through the web GUI, through the REST APIs, through command line, through all kind of different command line, specific language, specific libraries. And then there's also high throughput connectors. So why migrate EDW to BigQuery, right? So as I mentioned, first of all, a lot of companies are facing lots of costs and running existing data warehouses. So BigQuery allows you to reduce the cost significantly. We've also seen that performance improves quite a bit. BigQuery is well suited for hundreds of terabytes and petabytes of data. And on the longer running seminars, we actually have done where we loaded 2 terabytes, 3 terabytes of data in seconds, and then we were able to query it right away and just show the capacity and capability. New use cases, so sometimes people want to do machine learning, some maybe data sharing. Bring data into BigQuery allows to give them that capability. Analytics across data lakes and traditional data warehouses, that's another interesting use case where traditionally people had to build data lakes and data warehouses separately because of the difference in technologies and capabilities. With BigQuery, we think you can use actually the same technology, such as BigQuery land data allow it to be for consumption as a data lake kind of capability, and then process it and standardize and prepare it for data warehouse kind of use cases. And I guess the last one is that a lot of times when people build data warehouses, they didn't actually have backups, right? So because you're paying so much for a single appliance, the backups just were too expensive, right? So bringing data into the cloud allows you to facilitate backup use cases as well. So we gave a quick introduction into Looker. We gave a quick introduction to BigQuery and Google Cloud Platform. So now, why do we think these two are really fit well together, right? Before we go into more technical nuances, from a project planning and program planning perspective, we think that thinking about semantic layer and Looker early in a data warehouse implementation and migration phase is important. At the end of the day, the reason you're building data warehouse is for consumption, right? So BI layer, semantic layer facilitates that consumption through dashboards, reports, and with Looker, with LookML, which is semantic layer built right within Looker. Ignoring the consumption capabilities upfront a lot of times misses certain nuances that you might see as you start consuming data, right? So any storage, any technology, storage technology, database technology has its own nuances, like how you structure keys, how you partition, cluster, index, et cetera, right? Which is why we believe that doing a depth-first approach for these type of projects is super important, right? Pick a subject area. We typically recommend picking the most complex one because that exercises all kinds of use cases, and really drill down into it, right? And validate these requirements, assure completeness, reduce risk, etc. So we believe that looking at something like Looker for semantic layer is important early in the data warehousing migration space, not later on. So as we already spoke, Looker is a data platform, right? We think that there are really key capabilities that separate Looker from the rest of the BI cloud. So first and foremost, the data stays in your database, right? So you do not actually need to extract data in order for Looker to use it. Looker does push down optimizations on SQLs, and we'll see in the next slide what that means. But the data is being processed in your database layer. That is very important because with BigQuery, we have such amazing capacity and capability to work with data at scale. It really is able to exercise BigQuery's capacity without having to pull all the data out and do in-memory analytics. It's built using the latest technologies. So let's say if using the Google Cloud, you can actually have Looker deploy on its own Google Cloud platform or your Google Cloud platform, and lots of good integrations with third-party authentication systems, Web2 or GUI, thin client, fat client capabilities, et cetera, et cetera. And I think the last one probably is most important is that visualizations and tools for showing data are great, but unless you have what you're looking for, what you're presenting, it's not achieving its goal, right? So LookML modeling platform, which allows you to express your semantic layer, allows you to build independent semantic layer on top of your database that then is also available for your BI consumers to go and query directly or use directly. So how specifically Looker complements BigQuery? Scalability, cost, and unique functionality. So first of all, as I mentioned, on scalability side, because BigQuery push down optimizations are used and the processing happens within BigQuery layer, you are able to really use all the capacity that's available in BigQuery to do data processing, right? You don't need to extract it. You don't need a BI course and whatnot. BigQuery has a lot of interesting features that might not exist in other databases, such as repeated nested fields, which allows you to structure data models slightly differently, and let's say reduce number of tables if you're building a new solution. I mean, if you're migrating from existing traditional databases, you might not do it, but if you're building something new, we strongly recommend looking at. An example, if you have an order items could be repeated nested structure within a table without having to create a new table and have foreign keys and have to maintain it. Looker supports repeated nested fields as an example for the specific BigQuery capabilities. Looker also understands the BigQuery query optimization techniques, right? So each database has its own nuances as what's the best way to write SQL in a way that query execution plan is the most optimal, is the fastest. Looker writes what I say the most beautiful SQL for BigQuery you can see. It understands subqueries, filtering, partitioning, clustering, nested attributes, all those things. All of these capabilities means that you're actually spending less money than you would with the other tools, right? So on top of that, you can actually control costs with Looker by specifying limits as to how much data can your query process. So with BigQuery, unless you're buying a prepaid model, you're using a on-demand consumption. You are charged by how many bytes you are processing, right? So if you have a very large data set, it's easy to write queries that will cost a lot of money, right? So BigQuery allows you to, so Looker allows you to put limits where you say, hey, if the query is going to cost above X, don't run it, right? Which is good. You can also, as I mentioned, there is a BigQuery-specific capabilities that BigQuery, that Looker supports, clustering sharding, which improves performance. And you can also see the bad or BigQuery performance blocks, right? There's these different capabilities that allows you to actually analyze how your queries are performing from a cost perspective. And I guess the last one is when, as an example, when BigQuery machine learning capabilities came out about a year and a half ago, I think 2 years ago, on Google Next, Looker announced support for those capabilities at the same day when Google announced support for those capabilities. So this was 2 years before Looker purchased, before Google purchased Looker, and it just shows you how tightly integrated and forward-looking feature capabilities were between Looker and Google engineering teams. BigQuery GIS is another example where Looker has a very nice support for GIS type of use cases, mapping and visualizations. Which means obviously now with the BigQuery, with the Google buying Looker, means that these will just get more and more integrated. So I know Bruce already mentioned the architecture, but just to reiterate, the BigQuery would store the data, Looker data model platform, which is LookML. It's a configuration-based model definition, which then is used by different visualizations, right? And one thing to mention is that Looker it really allows you to provide what's called citizen analyst capabilities, right? So as you after you build your Looker model, you can obviously build reports and dashboards on top of it, but most importantly, you can also allow your maybe more power users to go and start exploring this the data themselves without having to know SQL. So they can build looks right within Looker platform without having to know all the joins and all the physical field definitions. Okay, so one case study, I think we're right on time, just want to mention. So we actually worked with one of the large and still working global logistics companies. They were migrating from Netezza and MicroStrategy into BigQuery, and they needed to rethink their BI layer. right? What are they going to do with the business intelligence going forward? We helped their BI team to define strategy of how to migrate the MicroStrategy plus Power BI reports into a new Looker-based environment, how to structure BigQuery data warehouse tables and partitions and slot utilization and other technical things to make the best out of the Looker platform. There was a lot of good lessons learned during the project here. There was a very large team, 20 plus BI people working on different models. So large team development use cases were important. One thing to mention is that, as Bruce mentioned, the Looker has very developer-centric development approach. So your code is checked into Git. You can work on specific branches. You have to, in order for code to migrate forward, has to merge into the production branch. There are capabilities to do migrations between dev, test, and prod environments. There is linter capability, so you can actually control how well your code complies to the formats that you agreed on from a governance perspective. What we've seen is that with the phase release that we've been working with the customer, there was very good feedback from the business users, right? So they came from MicroStrategy style reporting tool to Looker, and they were very impressed, right? The new style interface, ability to search for things quickly, the drill downs, the self-operation was huge because the BI team was inundated with small requests here and there. So this really allowed the business and Power business users to perform detailed kind of self-explanational sums about themselves. Okay. So one of the things I want to mention is that we're going to do 2 more webinars in the space. One is we're thinking that Looker governance for large teams, best practices might be interesting, especially if you have more than 2-3 developers. How do you deal with that? And then another seminar we're thinking to doing is a short rerun of, let's say, what we did about a year ago. Is how, when you bring a data warehouse to BigQuery, what are the different nuances that you should think about and worry about and be concerned. Now, one thing to mention is that with Zoom, you can actually do the Q&A. There are questions that you can ask if you're interested in, and we'll be happy to answer. So I'll wait a couple of minutes to see if there's any questions or answers that need to be answered. And while we're waiting for questions, Bruce, anything else you want to mention that I might have not mentioned in the past in my presentation?
No, I think you did a great job covering it.
Thank you. All right, and I see that someone's saying that the large teams using Looker would be very interesting. So that's great. Thanks for the vote. We will send out the details as when that seminar is going to be scheduled. Okay, let's see. I think we're getting a question. Question is, among all characteristics that are best in a relationship between Looker and BigQuery, what is the most impacting to your opinion? Great question. I think technical alignment between the 2 technologies is probably the most important. The fact that Looker is able to query BigQuery directly without having to extract the data from analytics, and the fact that it understands BigQuery specific dialect very well I think is the key. Okay. do you know when Looker will be fully integrated into Google? Well, that's, I don't think I know the answer, Bruce, unless you do.
Well, I'm not sure exactly what you mean by fully integrated, but we'll stay sort of as an overlay organization. So Looker will remain sort of a standalone piece within Google, still with the same multi-cloud support that we've always had.
Sounds good. I see another question here. In the current environment, what do you see as the biggest value add or ROI for Looker Google solution for enterprise? Well, I think people typically, the way we see it, right? Typically, people make decision to move away from existing data warehouse to, let's say, to Google BigQuery, right? And when that decision is made, they really have to figure out what to do BI layer. What we've seen is that existing technologies that they've implemented, business objects, Power BI, MicroStrategy, number one, they don't work very well with BigQuery in the first place, just because they're not, they haven't put engineering effort into it. And also, a lot of times, there's a lot of, from just implementation perspective, there's a lot of, legacy, dead wood in the implementation that really doesn't need to come along, right? So we think that bringing Looker into the mix really allows customers to think early about the consumption side of it, and Looker's semantic layer for LookML really allows to put a separation of concerns from the engineering to BI and to the end consumer reports, and provide self-service capability. So I think if one thing I would stress probably the most in the long term, I think self-service capabilities, which would stand out with the Looker implementation with BigQuery. There's a question about the slides. We actually will share the recording of this as a follow-up email, so that will be available. Okay, another question is, could you please share more about BigQuery performance blocks? Any link examples you could share would be great. Bruce, is this more specific to BigQuery or Looker? What do you think?
I'm happy to take this one.
Go for it.
So Looker has a number of what we call Looker blocks, which are pre-packaged sets of LookML models and visualizations to go on top of them. And we have one specifically for BigQuery cost and performance, so you can export data about BigQuery, and then you can just drop in this Looker block, and you can find it at looker.com/blocks, and just immediately start seeing, getting some more insights about your BigQuery cost and performance. And if you go to the website and find it, there's examples there of the pre-created dashboards that come with it to give you a better idea of what you'll be getting.
Thank you, Bruce. Any other questions? All right. Well, thanks everyone for your time. We appreciate you spending a few minutes with us this afternoon, Friday afternoon. Hope everybody's staying safe and healthy in these difficult times. And we will send out a follow-up email with a link to the recording, so you can review it or even share with your colleagues at your convenience. And we will also share an updated, we'll share information when the follow-up seminars will be held, so you can join us. Thank you very much.